So what is a relation? It's just a set of ordered pairs. An ordered pair, if you remember, is a combination of an x value and a y value, and it lets us be able to look at specific places on a coordinate plane. So let's graph 0, 0. Remember, each value of an ordered pair, the first value is x, the second value is a y. So the first value, the x, we use it to place it on the x-axis, which is 0. Then we compare it to the y value. The y value is 0, so it's already there. Remember, 0, 0 is called the origin. Very important thing to remember. Negative 2 is our x value of the second one, so we move to negative 2. Then we see that we need to go to positive 4, so we go straight up to positive 4 and we let it stay there. Now this last ordered pair is positive 3 for the x value, and the y value is negative 2. And we're done. We've now graphed 3 points successfully on the coordinate plane. Different ways to list ordered pairs. Obviously, we just went over this style, the x and y value being paired up in parentheses. Example number 2, instead of putting them in parentheses, it's where you would actually list them in a table. So this 5, 4 would actually be the same as writing it right here, 5, 4. 6, 3 would be the 6 is the x value, 3 is the y value. You get the idea. Vertical tables, exactly the same thing. Negative 3, 7. Is the ordered pair. Negative 3 is the first number, 7 is the second number. How can you keep the x and y straight? Say your ABCs, because it ends with x, y, and then obviously the alphabet ends with z, but x comes before y. So your first value is always going to be x. This is where more confusion happens. People just aren't used to reading a mapping diagram. It is pretty simple if you know how to read it. Think of it this way. We've got a set of x values on the left and a set of y values on the right. It's trying to show you a list of ordered pairs. It's showing you a relation, in other words. So we just have to pair up the x's to the proper y values. This 4 actually has an arrow pointing to 2, which means, hey, 4, 2 is what they'd like you to know is an ordered pair. 6, don't let the split arrow fool you. It just means that 6 is paired up with 2, as it is also 3. So 6 is paired up with 2, as it is to positive 3 as well. And then the last one would be 7, 3. So that's how you would read a mapping diagram. What is a function? A function just creates exactly one output for each input. So let's go through and take a look at what we're talking about there. Sometimes when we talk about inputs and outputs, we'd like to talk about there being an input-output machine. So I made like a fake machine here. This is the input side. We will input a number. It follows a rule and we get a new output. So 22 plus 7 is 29. I also know that 3 plus 7 is 10. And 5 plus 7 is 12. So it's the idea of we're going to take a number and we're going to do the same thing to that number no matter what the number is. In this case, the function is add 7. So any number we put in there will be 7. It also means this. If I take out another 3 and I put it through the same function, well, the function is still going to be add 7. So if I put a 3 in, it's going to get me 10. If I put 3 in again, it's going to get me 10 again. If I put 3 in a million times, it's always going to be 10. That's what a function is. It's got to follow that rule every single time. Is the following set of relations a function? So let's take a look at this. When I put 0 in, I get 2. When I put in 1, I get 2. When I put in, just look at this, 2, I get 3. When I input 3, I get a 3, and 4, I get a 3. Why am I looking at it this way? Because I'm going to say that x is the input, and y is going to be my output. So when we look at these tables, please keep in mind that it's like a secret code. Whenever you see X, you could say, I'm just going to call that the input. And when I see a Y, I'm going to think of that as an output. Did it follow the idea of each input has one output? Yes. Now, I understand that you're saying, well, the output's repeated. I'm not concerned with that. Really, the only thing I'm concerned with is, did my x's repeat? No. If my x's did not repeat, that is a function. Did my x's repeat here? Did my input, remember we can call that an input, did my input repeat? Yes, my 2 repeated. If this is a function, see, I know if I put a 1 in, I should get a 4 every single time if this is a function. If I put a 2 in, I should get a 5. So when I come over here and I check this 2 right here, if it's following some sort of rule, then I better get 5 this time. Let's see what happens. I did. So basically, every single input has its own unique output. Yes, 2 did show up twice, but did I get the same answer both times? Yes, it means it's following a rule. That is a function. Let's look at this. Did any of my x's repeat? Did any of my inputs repeat? Yes, 4 and 4. Well, when I input 4, it got me an output of 2. If it's a function, if I do that again, I should get 2. If it's not a 2, it's not a function. Oh, I got 3 that time. Not a function. So this relation, which just means it's a set of ordered pairs, is not a function because my input, it actually has 2 different outputs, and that's not allowed. Let's take a look at this one. This is a relation. It's a set of ordered pairs. This is my input side. None of them repeated. And because none of them repeated, it is a function. Now, it's probably bugging some people that the output's the same every single time. Here's how you can interpret this. Yes, it's a function because every single input has one output. When I put a -3 in, it's going to get me a 6. When I put in 100, it's going to get me a 6. When I put in 12, it's going to get me a 6. It looks like this function rule, as silly as it is no matter what the number is, make it 6. So if I put in 1200, it's probably going to get me a 6 most likely. But because the x's did not repeat, it is a function. Now, again, take a moment to pause this. The x's repeat. So when 0 gets me 3, if this is a function, it's going to be 3 down here. If it's not 3, it's not a function. Not a function. Because when I put 0 in the first time, the input-output machine, it got me 3. I put 0 in this time, and it got me 2. So let's take a look at an example of a function in a real-world scenario. There's a 120-pound person, and basically they burn 65 calories when they walk 1 mile. So my number of miles would be my input. Okay. So this whole row right here would be my inputs, which means that it's also known as x. What would this row be known as? My outputs. That's what it would be known as. Move that up a little bit so you can see better. There we go. So let's see if it's a function. If you walk 0 miles, you will burn 0 calories. If I walk 1 mile, you should burn 65 calories. Yes, it's following that rule. And then 65 times 2 is 130. And 65 times 3, if I walk 3 miles, is 195. So it's this idea of I input a value, 0, and the rule in this case is times it by 65. So 0 times 0 should get me an output of 0. If I put in 3, I should get 195 there. Why is this a function there? Each input has one output. 0, 1, 2, and 3. It did not repeat. That means that if I plug 0 in 100 times, I should get 0. If I plug in 1 million times, I should get 65 for this particular function. It's just this idea of it's following the rule every single time for any number you put in. What about this? Is this relation a function? This relation is a set of ordered pairs. Is it a function? I say yes. And remember, a relation is a set of ordered pairs, and a function is each input has exactly one output. 0 has one output. 2 has one output because 2 is always going to get me 8, and I can prove that because over here 2 still got me 8. So how many outputs does 2 have? 1. So each output has one input. Again, just in case you missed it, that's what a function is. And so when you see it, that's how we can identify it. Is this relation a function? Well, this 3 got me a 6. This input got me a 6. This 3 got me a 0. So this relation that I'm looking at, this set of ordered pairs, that's what this is. It's a relation. It might be a function. It might not. I can now say it's not a function because the 3's. Look at the inputs of the 3's. It got two different outputs. And so because of that, it's not a function. Okay, what about this? Let's use a mapping diagram. Is this relation a function? Yes or no, and why? Again, a relation is just a set of ordered pairs. We're just showing it in a different format. And the function at this point you should be more familiar with. Again, it's one output has, one input. Each input has one output. I'll get it straight there in a second. This 2 has an output of -2. This 8 has an output of -2. This 8 also has an output of 7, and that's where our issue is right there. That's what's causing this problem. So is this relation a function? No, because 8 has two different outputs. If it was a function, every single every single input would have one output. Quick practice, we're almost done. We're going to put a smiley face beside it if it's a function. We're going to put an X beside it if it's not a function. So let's look at this table. Does every single input have only one output? Well, the zeros all have one output. It's always going to be 0, and these two have it. So yes, this is a function. We'll put it right there. Okay. Now, what about this one? Does this relation a function? Yes, because every single input has one output. What about this right here? 3, 6, 7, 9, 4. None of them repeated. So yes, that is a function. Looking down here though, here's a list of ordered pairs. We really haven't looked at it being given in this format, but it's the exact same thing as the table. Let's compare our x's. 4, 4, well, that repeated. This 4 got me a 2. This input got me an output of 2. This input got me an output of -3. Sorry, it's got to get the same output every single time. This one is not a function. So to recap, a relation is a set of ordered pairs. Function is where each input has exactly one output. And can you tell if a relation is a function? If you can answer yes to that question, you've succeeded at today's lesson.